right, if you see a frequency table, the first thing I need you to do, add up the totals. All right, so in any probability, we need a big number for the bottom, and in a table, that big number is going to come from adding the totals up. Sometimes you might get a table that does that for you, and it says like total. But if you don't have that, then you need to find the total. So I added them all up, and I got 43. So the initial denominator, at least for all of my fractions, is going to be 43, and then I'll check to see if that simplifies from there. But at least at the start, it'll be a denominator of 43. So when it says water skiing, what fraction did you put for water skiing? 12, because next to water skiing is a 12, and then my denominator is 43. I don't believe that that fraction simplifies, so we're just going to leave that as 12 over 43. Hiking, 18. And then canoeing, 13. All right, all of those over 43. I would check if they simplify. They don't. All right. So next one says, a spinner has 3 equal sections colored red, blue, and green. A student conducts an experiment where she spins the spinner twice and records the results. The results are shown in the frequency table below. So I added up all the totals, and I got 23. Okay, so my denominators of my fractions are at least going to start at 23, and then maybe it might simplify. So the first question says, what is the probability of spinning red exactly once on the next 2 spins? So I've got to go through and look for red R 1 time. This is 2 times. This one's 1 time because it's 1 red and 1 blue. This one's 1 time, 1 red, 1 green. There's no reds in a double B, that's blue, blue. There's 1 red here. No reds, no reds. There's 1 red here. So I'm circling the instances where there's exactly 1 red. What should I do with those? Let's add them together. So we've got 9, 10, 11, 12, 13. Did anybody do this? 13? All right, so when I add 5 plus 2 plus 4 plus 2, I get 13 times where it was exactly 1 R. Out of the total, 23. So that probability is 13 out of 23. Those tables are a little trickier to read. Like, remember yesterday we had the one that was like heads, heads, tails. This is kind of similar to that. So just kind of understanding how to read the table and understanding what this is asking you for. Last one says, what's the probability of blue twice on the next 2 spins? So I'm looking for which outcome has blue twice. How many times does blue happen twice? Only once. So blue twice is this one. There's no other instance up here where there's 2 blues. So it would be 1 time out of the total of 23. So that probability is 1 out of 23. Questions on reading those tables? All right, that's what we did yesterday. Today we are going to determine if 2 events are independent, and then if they're independent, we're going to learn how to calculate their probabilities. So we're going to do that in our toolkit, and then we'll do some practice in our workbook, and at the very end you'll need your computers, but not until the very end. All right? So toolkit for now, open it to page 4. Just pull it on my calculator. Eventually I'm going to need that. All right. Independent events. When the result of the first event has no impact on the result of the second event. Okay? Independent. This one doesn't need this one. All right? So it says, the first example says, you choose a number tile from 12 tiles, then you spin an evenly divided spinner. are these independent? So let's think about the first event. I've got like 12 numbers in a hat over here, and I'm going to pick something out of the hat. Does what I pick out of the hat impact what I do over here, which is spin a spinner? Does the result of what I get out of the hat impact what I spin on the spinner? No. Like if I pick a 5 out of the hat, does that mean I'm going to spin a 5 on the spinner? Not necessarily, right? So one event has nothing to do with the other. These are independent. When there's no direct relationship between the two, we call them independent. So are these independent events? Yes. And I'm going to like give a reason. You don't necessarily have to write this if you don't want to, but I'm going to because it's a toolkit note. So yes, the result of event 1 does not impact event 2. You pick a card from a set of 15 sequentially numbered cards. Then without replacing it, you pick another card. So I'm like, okay, Bryce, here's 15 cards. Pick one. He keeps the card. And then I go, okay, Emma, you pick one. Does what he get impact what she gets? Because if he picks a 2, he keeps it. Can she pick the 2? No. So his result impacts her result. That's dependent events, all right? So for this one it says, are these independent? No. Because the result of event 1 changes, that's a C by the way, changes outcomes for event 2. These are independent when they don't impact each other. They are dependent when they do impact each other. All right, you roll a number cube and then flip a coin. No. Does what I get on the dice impact what I get on the coin? No. These are independent. So now we know what it means to define something that's independent versus dependent, right? Once you know they're independent, there's a formula for them. So there's a way that you can calculate their probability, all right? So here's the formula. The probability of event A and B happening is the probability of event A multiplied by the probability of event B. The word "and" in probability is always associated with a multiplication symbol. And means multiply, all right? So I'll find the probability of the first event, and I'll find the probability of the second event separately, and then for both of those things to happen, I'll multiply the 2 events together, all right? So the first one says, you choose a number tile from 12 tiles, then you spin an evenly divided spinner. We determined that they were independent. So now we want to actually calculate the probability. What's the probability you choose a multiple of 3 from the number tiles and spin a 4 on the spinner? So let's think about the number tiles. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, those are the numbers on the number tiles. Let's highlight. Let's highlight the multiples of 3. 3 is a multiple of 3. All right. So there are my multiples of 3. So to find the probability of a multiple of 3, I'm going to think about how many multiples of 3 there are. We highlighted 4 numbers out of a total of 12 numbers. All right, there's 12 total numbers here. And then remember, we always want to check if that reduces. So 4 divided by 12. Math, enter, 1/3. All right, so that probability is 1/3. All right, and then we have a four-sided spinner, right? And it says, what's the probability you spin a 4 on the spinner? How many numbers on the spinner are a 4? 1 out of 4. Right? So we find the two probabilities separately. Now, if I want both of those things to happen, the likelihood is going to go down, right? One thing is going to happen, that's one probability. But if I want multiple things to happen, the chances of those things happening decreases their likelihood. So when we multiply these, we're going to get a fraction that's smaller than both of them, all right? So if I want both events to happen, the probability of getting a multiple of 3 and a 4 on the spinner, if I want both of those events to happen, and is in the middle, what is the probability you get a multiple of 3 from the number tile and spin a 4, and means multiply. So I'm going to take the probability of the multiple of 3, which was 1/3, and means multiply. The probability of getting a 4 was 1/4. I don't need you to know how to do this in your head. You can do this in your calculator. Okay? So you can hit alpha, y equals, and you can get them to look like fractions if that feels better to you, like so you can see it in fraction form. Or you can put each fraction in its own set of parentheses. That works too. You just need to tell your calculator which numbers belong to which fraction. Otherwise, it's going to look like one really big fraction. All right? So I'm either separating them like this, or I can do this alpha y equals, and I can get a fraction like this. You just have to do it again when you want the other fraction. So alpha y equals. Not all calculators will let you do that though. So you can just test yours out and see if it can. But 1/3 times 1/4 gives me 1/12. If you do it like this, and you get a decimal, just make sure that you math, enter that decimal. You're getting 1/12 either way. All right, so the answer to this question is 1/12. The chances of both of those events happening simultaneously, one after the other, is 1 out of 12. I take each probability separately and then I multiply it together. The next one says you roll a number cube, then flip a coin. We determined that they were independent. What I get on the dice is not going to impact what I flip on the coin. No relationship, independent. So now it's saying, well, what's the probability that you roll a factor of 5 and flip a tail? So let's think about the cube first. Those are the numbers on the cube, right? Factors of 5 are numbers where I can take 5 and divide them and get a whole number. So like 5 divided by 1 is a whole number. 1 is a factor of 5. 5 divided by 2 is a decimal. So 2 is not a factor of 5. 5 divided by 3 is a decimal. 3 is not a factor of 5. 5 divided by 4 is a decimal. 4 is not a factor of 5. 5 divided by 5 is a whole number. And 5 divided by 6 is a decimal. So my factors of 5 are 1 and 5. They're the only two numbers that multiply together to equal 5. All right? So to find the probability of a factor of 5, well, 2 out of my 6 numbers were factors of 5. All right? 1 and 5, 2 numbers, 6 total numbers. So 1/3. Now I'm flipping a coin. Those are my options on a coin, right? I'm going to get heads or tails. I want to know what's the probability of getting tails. Well, one of my options is tails out of 2 total options. So I find each probability separately. And now if I want both of them to happen at the same time, or one after another, what is the probability that you roll a factor of 5 and flip a tails? I'm going to multiply them together. And means multiply. So I'm going to take the probability of the factor of 5, which was 1/3, and I'm going to multiply it by the probability of getting tails, which is 1/2. I can type that into my calculator. You don't have to do that by hand. You can use parentheses around your fractions. Just when you get a decimal, math, enter that decimal. Or alpha y equals will give you this fraction in some of your calculators. Some of yours won't have that option, so you'll have to use the parentheses. If you do it this way, though, it'll immediately put it in fraction form, so you don't have to do the math, enter. So this probability is 1/6. All right, a desk drawer contains 5 red pens, 6 blue pens, and 3 black pens. The next desk drawer contains 24 silver paper clips and 16 white paper clips. If you randomly select a pen and a paper clip without looking, what is the probability that you select a blue pen and a white paper clip? These are independent because even if they were in the same drawer, I would really hope that you know the difference between the feeling of a pen and a paper clip, right? So like me picking a pen is not going to impact the total paper clips. Fair enough? Independent. The result of the pen isn't going to affect the result of the paper clip. They're independent events. So now I'm going to calculate each of their probabilities. So the first event says that I want to pick a blue pen. All right, well, how many blue pens are there? 6 blue pens. Out of what? Where are you getting 14 from, Andrew? 5 plus 6 plus 3. You need the total pens, right? So I've got to add those up. So that's 14. All right, and then I can reduce that. Your calculator will reduce it for you. You don't have to be able to do that. All right? All right, let's see. Probability of a white. I'm just going to say PC, paperclip. All right? So the desk drawer contains 25 silver and 16 white paper clips. There's 16 white paper clips. What's my denominator? Where's the 40 coming from? Adding the paper clips, 24 plus 16. Divided by 4. 10. No, 8. Divided by 8. 2 fifths. Okay, 16 divided by 40. You could just type that in your calculator. 16 divided by 40. Math, enter. 2 fifths, right? You don't have to be able to get that fraction on your own. So now the probability of both blue pen and white paper clip. Taking the blue pen, and means multiply. I'm multiplying each probability separately. So 3/7 times 2 fifths. Math, enter. 6 35ths. Really the only thing that multiplication of fractions is the top number times the top number, the bottom number times the bottom number. 3 times 2 is 6, 7 times 5 is 35. What do we think? First, determine that they're independent, right? If they're not independent, this formula doesn't work. Okay, so they need to be independent. And then, once they are independent, and you want two things to happen, you multiply them together. All right? So you're going to try some in your workbook really quick. On page 6, again, the page numbers are kind of funky here. So if you're not sure if you're on the page 6, because some of them have multiple page 6s, there's a screenshot on the board of what it should look like. All right? It's got a spinner. And we're doing 3 and 4. Really quick examples. I have 5 minutes posted there. I don't even think we'll need that, but I'll check it in a few minutes. Make sure you're reading, because it's not just the spinner you're looking at. It says you spin the spinner on the right, and also you're picking a tile from 1 to 10. So those are the two events, spinning the spinner and picking a number from 1 to 10. The spinner is the first probability, the number tiles is the second. You need a visual. There's some on the board. All right, probability of getting an odd on this spinner. 2 out of 4, 1 out of 2. All right, so 2 out of 4 numbers are odd. We're going to reduce that to 1 out of 2. All right, what about evens out of these guys? 1/2. 5 out of 10, or 1 out of 2. So if I want both of those events to happen, 1/2 times 1/2 is, you tell me. 1/4. So the answer to this first one is 1/4. All right, probability of getting a number less than 4. How many numbers on that spinner are less than 4? 3. All right, probability of getting a 9 or a 10. How many numbers on the tiles are 9 or 10? 2 out of 10, which is 1/5. All right. So both of those things happening is 3/4 and means multiply 1/5. And you got 320. All right. What do we think? We okay with that? The goal for today was I can determine if 2 events are independent. So like I can give you a scenario and you're going to tell me, yes, the relationship of the first one impacts the second one. They're not independent. Or they have nothing to do with each other, right? They're independent. So that was the first thing. And then now I know they're independent. Now I can actually do some calculations. I can find the probability of the 2 events, multiply them together. That was the goal. We're going to test it with our closure. Now, this closure is more than just that. It is a summary of the week, okay? You're going to see experimental probability. You're going to see theoretical probability. You're going to see complement probability. You're going to see relative frequency and independent events. If you check the backboard, I made like a little cheat sheet for you of all of the things we did this week, right? If you're stuck on any or you don't know what those words mean, turn to the backboard, see if that helps. If it doesn't help, it's multiple choice. Make an educated guess. All right. Feedback will pop up when you're done. Read the feedback. If there's any that like are really red when I'm looking at this, like 50% of you got this problem wrong, we'll go over it when we're all done. Okay. We're going to go over the big ones when we're done. All right. So you are going to take your time, please. Okay. This is content from the whole week. Here's my room name. Once we are all finished, we'll go over what we need to go over. You will need a calculator, I assume. So if you don't have one out already, don't know how you got this far, but take one out. All right, here are our results. Not bad. I'm going over anything that's not proficient. Proficient is 70% or above. So, let me unfreeze this so you can see it. So, 2 of John picks a brown M&M from the bag of candy. He eats it and then picks an orange one. They are dependent because he's eating it, right? So anytime the total changes from one event to the next, that's dependent, okay? So the fact that, like, let's say he has 20 M&Ms, he eats the brown one, now he's got 19. So that next M&M is impacted because there's less. Does that make sense? So anytime the total's impacted, it's dependent. So this was dependent. And then the other one like that was 7. It's the fact that the cards replaced. Do you guys know how many cards are in a standard deck of cards? Apparently that's not common knowledge for your age anymore. It's crazy for me that kids don't know that. But alright, so I've got 52 cards, right? I pick one, but I put it back. There's still 52 cards, right? But if I pick one and I don't put it back, now I'm looking at 51, the total changes, all right? The fact that I put it back, it's still 52, the total doesn't change. That's why this one was independent. But if I didn't put it back, it would have been dependent. So it's the replaced it card. Now, in terms of the final 2, it says you spin an 8-sided spinner and then roll a 6-sided die. What is the probability that you spin an even number on the spinner and a number greater than 2, not including 2, on the die? I think there are a few layers of things happening in these problems. One, are you getting the 2 probabilities right? Because if you get one wrong, then your answers are wrong. 2, are you multiplying them? Like, are you getting the concept from today? And 3, are you lazy and you're not using your calculator? Just trying to do it in your head. So there's like a few things happening that I think are making these numbers lower than they should be. So I listed everything out. Let's just make sure you have all the parts. All right, so It says if we are spinning the 8-sided spinner, we want to spin an even number. So here are my even numbers on the spinner. For even numbers, there are 4 out of 8 numbers on the spinner are even. So that is 1/2. All right, so that's my first probability. My second one says that I want to get a number greater than 2, not including 2. I want it to be bigger than 2. 3, 4, 5, 6. All right, so 4 out of the 6 numbers are greater than 2, and then that reduces to 2/3. So like the first piece is, are you getting those right? Maybe you're picking 2 and you're calling it 5 out of 6. So just make sure you check that. And then for both of them to occur, we're multiplying them. Let the calculator do the math for you, okay? If you multiply straight across, you get 2/6, but the calculator will reduce that for you to 1/3. So like type that in the calculator, use your parentheses, or use like the alpha y equals, make it a fraction. When you multiply them, you get 1/3. All right, so that was the first one. That wasn't as low as the next one. I think only 3 people in the class had this one right. All right, so my guess is you're getting one of these wrong, and it's leading to the wrong answer. All right, because there's some vocabulary in here, the word multiple and factor. All right, so the first one says you get a multiple of 3. So if I'm looking at multiples of 3, multiples of 3 start with 3, and they multiply, right? They're multiples multiply. Multiply means they get bigger. Multiples of 3 can't be smaller than 3. 1 is not a multiple of 3. So multiples of 3, 3, 6, and 9. So 3 out of the 10 numbers are multiples of 3. Factors divide, so they get smaller. Factors are smaller than the number. So I'm looking for factors of 20. 20 divided by 1 works, 20 divided by 2 works, 20 divided by 3 is a decimal. 20 divided by 4 works, 20 divided by 5 works, 20 divided by 6 is a decimal. 20 divided by 7 is a decimal. 20 divided by 8 is a decimal. 20 divided by 9 is a decimal. 20 divided by 10 works. All right? So those are the factors of 20. You need to make sure you know what that means, right? Because if you don't know what a factor means, there's no way you're getting the answer right. All right, so 1, 2, 3, 4, 5 out of the 10 numbers, or 1/2. All right, and then finally, once you have them separate, that's when you can multiply them together. The answer was 3/20, and I think only 3 of you had that one right. Questions? All right, so that's a summary of the week. I don't think it was bad. I mean, this stuff was new today, so I'm not as concerned of you getting those problems wrong. I don't have any homework for you over the weekend. Feel free to grab your phones. We are done.